Hey everyone, welcome back. This will be the last video for chapter 5. Um, so we're going to revisit this question, right, where we're given an area under the curve, and we want to know for what cutoff value, what value do we need to be at in order to obtain that area under the curve to the left or the right, depending on how the question asks it, right? So we're sticking with our IQ score examples here where IQ scores are normally distributed with a mean of 110 and a standard deviation of 10. And we want to know what the minimum IQ score is required to be in the top 5% of this population. So I'll draw this out really quickly, but and I apologize. I'm not using an actual mouse this time. I wasn't going to do this. Right, but if our mean is at 110, right, and so on, what we're asking is what scored down here, right, from 110 through 120, 130, 140, and so on, what score do I need down here so that 5%, I'm at this cutoff right here where I am in the top 5% of scores. So there's some X value here, right? That would give me only 5% or 0.05 area under the curve to the right of me, right? Because I'm right at that top fifth percentile. Um, so I've got 5% of, the data, the population, 5% of IQ scores are above me, but I'm right here, right? That's the minimum IQ score needed to be inside the top 5. Well, if 5% are above me, we know our total has to add up to 100. Then that means here in the green, all of this, right, is going to be equal to 0.95 below. Okay, so I'm looking for 5% above and 95% or 0.95 below me. So we're given this area under the curve, right? We're given the 0.05, and from that we kind of deduce the 0.95 to the left, which we'll need here in a second. And what we're looking for is a specific value of IQ scores, right, to meet this area under the curve. So how can we do this in our calculator? Let's pull it up. We can go back to second and second var, sorry, to the distribution list as we have been. But this time we don't want to choose normal CDF, right? Normal CDF gives you an area under the curve when you know that value down there on the x-axis, right? You can plug in an interval, so you can plug in two x values, right? Two IQ scores, and you want to know the area under the curve or the probability that you're in between those two, or you can plug in negative, positive, infinity, right, and a lower or an upper. And that returns the area under the curve. This time we're given the area under the curve, and we want to know what our kind of what our lower or our upper value should be, right? So to do this, we're going to choose option 3, which is the inv norm or the inverse norm. If I hit enter on that, you can see it asks for an area, a population mean, and a population standard deviation. Mine is a little more advanced. The actual physical TI-84 calculator I own does not give me this option, so I'm going to kind of ignore it because I don't know if you have this option at home or not. The traditional TI-84 calculator will always assume that this area you're giving it is to the left, okay? So just imagine we don't have this option and we have to give it the area to the left. That's why we had to find that 0.95 earlier, right? Again, if we're in the top 5% on the top side, the right-hand side, that means we have 95% of IQ scores below us. So again, the area under the curve to the left that we're looking for is 0.95. And then this is just the population mean of our IQ scores, right? That was 110. And this is the population standard deviation of our IQ scores, which we're also given is 10. Again, just ignore this and we'll hit enter and enter again. And so what this is telling us is you need at least an IQ score of 126.448 or 126.45 if you wanted to round to be in the top 5% of all IQ scores according to that distribution. And that's the answer. This is a lot easier, right, than plugging in the finding the area under the curve, right, inside of our z table. It's how we had to answer this question last time. We had to find that 0.8997, which was the closest to 0.9 we could get. I think the last time we looked at this, we wanted the top 10% of IQ scores, right? So we found that 0.9, which again was the area to the left. And we found our z value of 1.28. So we took that z value and we took the of 1.28, plugged that in here, plugged in our population mean and standard deviation, and we used some algebra, right, to solve for x. So using the calculator is a little bit easier than doing all of that.